Good day. This is lecture 5 or module 5. The topic is computer communications networks, delivered by Dr. Abdullahi Salihu. The learning objectives. So upon conclusion of this section, the student will be able to give a sound definition of network and its component, and list some common benefit of a computer network, state the different classification of networks, and of course types, identify the types of computer network. So what is a computer network? So a computer network is the interconnection of two or more devices through a communications medium in order to share common resources. So for you to have a computer network, for us to have a computer network as a setup, you need at least two devices that one can be the sender, one can be the receivers. These two devices are connected using the appropriate communications medium. So it can be connected using the wires, which can either be the copper cables or the fiber optics, or it can be connected using the wireless. So these devices are connected together in order to share resources. And there's one fundamental thing that a given network must exhibit, that is the protocol, that is the rules. So for a network to be good, for you to have a sound network, those devices that are connected to share resources must operate under a given protocols. These protocols are just a set of rules. There must be rules. There must be rules that governs the communications. There must be, without an appropriate rules, your communication, your network setup might not be very effective. You take, for instance, where I can demonstrate the use of a good protocols. If you send an email, it is expected, if the mail is not delivered, you receive an acknowledgement. You receive a message that your mail could not deliver to the probably maybe the address you set is not correct, or any other reason that might occur. So if you did define a protocol that when you send a message and the message failed to deliver, it should communicate the sender. If that is not defined within the rule that govern the network, it means you might send a message and the message will not deliver, and you won't receive an acknowledgement. Receiving the acknowledgement is because of the protocol that was defined when the network is being formed. So a node is a technical terms. It can be a computers, it can be a mobile devices, could be a router or IP telephone. These are nodes that are communicated, that are linked together within a communicating a network environment. So we have transmission mediums. Yes, we have the wireless and the wired. The wired was mentioned earlier, that use the copper cables, and then the fiber or optic cables. Then the wireless that uses the radio frequencies to connect the devices within the network environment. So what are the requirements? What do we need to set up a network? So for any of these devices, any of these attributes, any of these tools, if it is not there, you have difficulty in having a computer's network. For you to have a network setup, you must have at least two computing devices, as shown on the screen. You have your computer devices connected to a server, or then you have a communication medium. If you look at it, the two devices are connected with a dark line. That shows a communication medium, and that communication medium, of course, it can be wired and it can be wireless. But this is just for explanation purposes. Look more like a wire, but then you have the network interface card. For any devices to participate in the network, it must have the network interface card. It must have. So part of the troubleshooting when our communicating devices fail to to reach one another is the first thing, or one of those things we check is if the network interface card is functioning or not. So it must be functioning, it must be there, and it must be functional for you to have a network setup. Then the network operating systems, you need a network operating systems, a Windows-based network operating. Typical example of a network operating system is the Windows-based Microsoft server that is used as an operating system for your network setup. You have a switch, of course, which is used for switch the data from the first point to the second, and vice versa. So there are different types of network configurations. There are different ways you can configure your network. There are different ways. Broadly speaking, there are two major types of network configurations. There are peer-to-peer network configuration and client-server applications. So in the point-to-point applications, the first one by the left, the point-to-point applications, all the computing devices have equal power. They are connected together and they can share resources within themselves. The main attribute or main characteristics of the peer-to-peer networks is they all have equal power. They all have equal power. They can share resources, but none of the participant is superior to the others. And this type of traffic in this type of network setup, since you have, when the network begins to grow, so you find out that the collision domain tend to grow as well, and that will lead to a lot of collisions of data, of packets sent within this network environment. To correct this, the next network configuration is the client-server configuration. And this is the most popular configuration type, the most effective, the most used types of network configurations. At the center, you have your server, and all the computing devices are connected to the servers. These types of relationship, it's often called the slave masters relationship. The clients, which are the computer devices, are the slaves, and the masters is the server that coordinate, that regulate, that ensure who use which resources at any given point in time, sensing the part of communication and ensuring that the part of communication is empty before accepting a communication from another devices. And in this case, what it means is your collision in this type of network configuration will be reduced drastically. Your collision will be reduced drastically. The first one, which is a peer-to-peer thing, where you easily use it when you want to share resources with your friend in the class. You have a lecture material you want to share, you share it using Bluetooth. Is a good example of a peer-to-peer network. But as the devices are growing, it's bound to a lot of collision, or the collision domain tend to increase as well. So what are the benefits of computer network? There are numerous benefits, but here we just list three broad benefits of a computer's network. We have the file sharing. So in most cases, we comes together to form a network so that we can share files. Most of what we download materials from the internet. What we typically do is, well, it's a file sharing. These files are in a server or in a computer somewhere around the globe, and you connect to it to download the file. What you're doing there is you're sharing a file. Or within your class as a student, I downloaded a material, or I have a very good soft copy of a material that my aide are studying. We can easily connect either through our USB cables or through Bluetooth or any of the wireless connection to share these resources. So when we share file among ourselves, being within the peer-to-peer configuration or within the client-server configuration, like you downloading from a server from somewhere you don't even know, it's all fall within the realms of sharing, or the benefit of computer network as the sharing of file. Sometimes we can share resources in an organizations. Instead of purchasing a file or a printer, I mean a printer for each offices, you can dedicate that and get a single printers. And in a network configurations, the multiple users can all connect to the printer and print their whatever thing they want to print. In that case, they're sharing. The computer network provide you the capability of sharing a printer within the network environment. And the computer program, sometimes the program we use, like the Microsoft Office, sometimes even the operating system, some programs that are very expensive, like those in the science that want to use the MATLAB, you can get a multiple you can get a server version of it, install it in the server so that the users can access it or use or perform the tasks they need to use MATLAB to do. Like the Microsoft Office, if we have it in our server, I may not need to install it on my system. We can share the one within the in the server. In that case, we are always sharing programs. So looking at the computer network setup, we want to look at define some terms that revolve around computers network. The internet. We have the internet, we have the internet service provider, we have the firewall protocol, and the dynamic host configurations protocols. The internet is the largest network. It is the largest network that connects the entire, or they connect the global network together. The internet, very fortunate, it is not owned by any person. That's the beauty of humanity. It is not owned by any person. Of course, there are resources. There are resources that are used within the internet, and those resources belong to an individual or organization. But the internet as a whole, which is the network of all the networks, does not belong to any person. And internet is so important. It's so important in our daily lives that most of us, we don't spend 1-2 hours or even less than that. If you take the average time we use the internet, sometimes it is less than, because if you access the internet 24 times in a day, it means you are accessing the internet average of 1 hour at everyone. Some go beyond that. So internet have formed a very important components of our life. Our life are so dependent on it. A lot of the application we use are dependent on the internet. Then you have this, the next is the internet service provider. Internet, if you want to use the internet, you need services. You need to access, when you want to access the internet, you need to be given that service through what we call the internet service provider. Most of us use our mobile phones. If you're using an MTN, of course, MTN is your internet service provider. If you use your Glo network, your Glo in that case is your internet service provider. Aside this telecommunication industry, there are some organizations, dedicated organizations, that what they do is provision of internet. They provide internet service and other services as defined by their role. A typical example is the Galaxy backbone. Galaxy backbone, primarily they provide the data service, and where organizations stores their data in their cloud support programs, or sometimes they provide internet services too. If you very soon, I believe our university will get connected to the internet as provided by the Galaxy backbone, where we learn they have laid their fiber optic, because the fiber optic runs and passes through the roads in our gate from Abuja to Akwanga to Makurdi to their Enugu or the instance data center. So once they have laid the fiber from the junction at the gate there to the ICT center, and what is like, if they're able to give us the internet, then from there it can be distributed to all parts of Unsuk and will enjoy a higher rate of internet service. And a firewall, just like the names imply, it's a wall built of fire. It's a defensive wall that defends either your network or your computing devices against internal attack, checking all traffics that are coming into your network, looking at it, checking traffic that may be harmful. Those that are considered to be harmful to your network or to your computing devices are stopped from entering your network or your devices you're using to access or to access the internet or participate in the network. So a firewall can be implemented as either a software, it can also be implemented as a hardware. So in whatever case, it is primarily designed to prevent or to restrict, to prevent those traffics that are considered or that may be considered to be harmful to our network or to our computing devices. It prevents them from entering. And a protocol, yes, I've mentioned a protocol when we're defining a computer network. It's a kind of a rules, because for you to set up your network, you must define, you must attribute. Like when we come to our physical class, that is a network. A setup. The student and the lecturers form the nodes that make up the network. The lecturer probably is the server, so that is going to be a client server's architecture in our network configurations. There's the lecturer being the server. The students are client that connect to the server to share our resources. So in that type of setup or a network setup, if you don't appropriately define these protocols, for instance, if you're defining a protocol, remember we say a protocol has a set of rules that governs a network. So if we don't define a very good rules, ordinarily we can say when we're defining a protocol for our physical class configuration or setup, we can say one person should talk at a time. We are not saying one person should talk at a time just to display the superiority of the lecturer or the superiority of whoever want to talk at any given point in time. The essence is if one person is talking, all the other people, all the participants listen to the person and they benefit from what they're saying. But if everybody is talking, we will not talk, we will not understand one another. So this protocol is set. So if you want to talk or when a lecturer asks questions, the protocol is raise up your hand. We're saying raise up your hand so that one person will be chosen, so that one person will talk at a time. So you can see these are set of network, these are set of protocol. These are set of protocol we define. It's a set of protocol we define in order to govern our physical class network configurations. Then the dynamic host configuration of protocols. Yes. Dynamically, when you join in or when you want to participate in a network, in most cases in these days, except for a dedicated devices that might require the IP allocations or the name allocation or the participant's name allocation in the network should be assigned to them statically. In most cases, it is being assigned dynamically. It has been once you join the network, there's a pool of the name, that is the IP address within the network setup that will just be allocated to you automatically. If you are connected to an internet, for instance, if you are connected to an internet, if you check the IP address at that point, at a given point in time, if you look at your IP address and then you stay for a long time without accessing the internet. So probably part of the protocol, part of the rule is if a session is established between the communicating devices and if it remains idle, maybe for 10 minutes, that section should be terminated, because whatever section you have, the connectivity, it demands additional resources. That is why in the network environment, it is terminated. Depends on how you agree or depends on the protocol you define. So if you connect to the internet and after some time, maybe 10-20 minutes, your system remain idle without communicating with the server. You discover that when you log in, sometime, or in most cases, if you go back to check your IP address, you find out that the IP address might not be the same. This is because the dynamic host configuration protocol, once you are disconnected and somebody come in at that time you were disconnected, your IP address you have been using at that particular point might be reallocated to the other person. So when you decided to join the dynamic host configuration, the protocol might decide to give another person that just come in. So classifications of a network. So a network device can be classified using the following criteria: geographical span, interconnectivity, and on the basis of architecture. On the basis of the geographical locations, your network setup can just cover a tabletop. It can just cover within a tabletop, and within a few ranges of meters, where you can use a Bluetooth as a communications medium. You can use the infrared. So within a tabletop, we call it the personal area network, or your network might spread across a building, including computer via computer media to connect your network. So geographically, your network can just span within a building or a flow of a building, or it may span across the whole city. Network spanning across the whole city. You can see how it is going from a tabletop to a building to a whole city, or it must span across multiple cities to provide, or provinces, to cover multiple cities, which is the wide area network. When it cover a whole city's metropolitan area network. When it cover a building, it's called the local area network, or it may be one network covering the entire world, which is the internet as we defined earlier. Classification of network: geographical span. A network device may be connected either logically or or this is supposed to be a classification on the basis of configuration. Yes, this is not geographical. The first one is geographical. This is on the basis of not geographical, but this is a configuration on a classification on the basis of configuration. So your network devices may be connected either logically or physically. Logically is telling you the connectivity of your network on the basis of the IP, how your IP addresses are set up within your network environment. Then it can be connected on the physical. This is where we describe the topology, where we're going to look at the next slide. So in terms of the interconnectivity, you can look at the physical design and the physical connection. So on the connectivity, you have the logical connectivity, and then you have the physical connectivity. The logical is on the basis on the connectivity of your IP addresses, and then the physical connection is looking at the physical, that is the network topology that we're going to look in this section. On the network, on the architecture, you have the peer-to-peer. We have explained that on the configuration. Peer-to-peer network architecture, where you have two or more computers with equal power come together to share resources. Then you have the client server architecture, where you have your clients, many clients, and the server. Whenever you access the internet, you are downloading, you type your www.unsub.ng. that network setup is a client server. The unsub.edu.ng is actually a server located in our ICT that you can from your browser, you interacting from your browser, so the client side of it, and the server you are interacting with is your client. When you say www.facebook.com, you're actually interacting with a particular server. So such network setup is we call it the client server architecture. And of course, sometimes you could have a network that exhibits both the attributes of the point-to-point or peer-to-peer architecture and the client-server architecture. Such type of network is referred as the hybrid computers. Hybrid architecture. Then we look at the types of computer networks. You have the personal area networks. If you look at the personal area network, you have two devices connected using the Bluetooth. So a personal area network is just about 10 meters. That is why we call it a PAN. We call it personal area network, just a table, a network that's span within a table. We call it a personal areas network. So our communication device, communication medium in this case is wireless, which is a Bluetooth radio frequencies, and then you have the local area network connected reside in a small geographical location, such as a floor of a building, a complete building, or even a whole campus, but under a single administrator, a network administrator. Yeah, this is very important because you could have a very small area, you have a network within that small area, and if they are not under a single administrator, that network is not considered. The fact that it is just within a room or it's within a building, it is not a local area network. For it to be a local area network, it must be under a single administrator, and it cover a relatively small location, such as a building or a campus. Sometimes campus area network, buildings, or a floor of a building, a very small area. So we're looking at it in relationship to the area or the space it cover. But remember, it should be under a single administrator. It's very important point as far as defined in a local area network. So this diagram showing two printers maybe connecting computing devices from two different floors within a building or two different locations, and the switch are connected together. You have your file printers where you have your files, file servers where you have your share file. The workstations are connected such a way that they can access the file, the shared resources. You have the Metropolitan area network. Remember, we say Metropolitan area network is a network that covers or span the cities. So it's made up of one or two local area network. Then wide area network? Wide area network, of course, relatively it covers a larger geographical area than the LAN and the MAN, not one, such as states, region, or even a country. A network connection may be LAN and or a MAN using sophisticated equipment like fiber optics and high-grade routing are needed for effective WAN connectivity. And now, having looked at that, we look at the topology. How are this network connected physically? Because it's your connectivity affects the performance of your network. If they are not well planned on how they are connected, either on a logical perspective, which is your IP having a sub-network defined within your larger network. If you don't do that, if you don't segment your network, it means you are bound to have a larger collisions domain. So logically, connecting your network effectively and physically connecting your network effectively improve the performance of any given network. On a logical connectivity, we say that is described on the basis of the IP address. So the scope, it is beyond the scope of this class to begin to see how these IP addresses are segmented for effective network. But have it in mind that for you to have effective computer network, it needs to be segmented logically correct. Otherwise, you have a low output as far as your network configuration or network output is concerned. So first, in the physical topology, we'll look at the point-to-point topology. So the physical topology describes how the various network components such as the cable, router, switches, computing devices are connected to one another. So the first one is a point-to-point topology. So in the point-to-point, you have your two computers connecting to one another to share resources. This is glaring when you look at when you want to share your resources, the pictures using the Bluetooth. When two computers are connected using the Bluetooth, you share a picture, to share resources, or to share whatever file you need to share. Such connections referred to as a point-to-point connection. Sometimes it might not be Bluetooth. You can use a wired also to do such type of a connection. Then you have the bus topology. In the bus topology, what's major attribute of a bus topology is you have a common communication mediums. So all the computing devices are connected to the shared communications medium. So one of the major drawbacks of this type of topology is if there is any problem with the line, with the communication mediums, the network will be down completely. Also, when two or more devices want to send a message at the same time, it might lead to collisions. So it might lead to collisions. So there are lots of collisions. CSMA, carrier sense multiple access / collision detection or collision avoidance, tools that have been used to improve on this, to sense the communication part, to see if node A or computer A is not already using the shared resources. But on a whole, this type of network topology is bound to have a greater collisions domain. And the major drawback is once the communication part is down, your network tend to be down. Yes. So the star topology. This is when a hub. So in a star topology, you have a communications devices like the hubs or the switch. Then you have your computer connected to it, or it can even be a server, and your computer are connected to the server. This is when a hub or switch connects all the other network devices. The connection between hub and other network devices, point to point. Yes, the major disadvantage is that it has a single point of failure. Yes, it has a single point of failure. That device is in the middle, whether the hubs, whether it is switches, whether it is the router. Once it fails, the entire network is down. So the major drawback of this type of network configuration is it has a single point of failure. So once the devices at the middle gets is down, the entire network is down. So layer one is when your hubs and repeater is used at the connecting devices. Well, so when you use a hubs is almost a legacy device. Now you hardly found it because it has so much collision. The collision domain of a hub is very high. So it's almost a legacy device. It's not used, but for academic purpose, we'll tell you that yes, a hubs can be used, and when a hubs is used, we call it a layer one, and it is a layer two when a switch or bridges are used to connect the devices, and it is layer three when a router or gateway is used to connect the devices. Today's most of these devices, you have a router, an integrated router that have a router, it has a switch, so you can connect. And the switches, so you have intelligence switches in these days that performs a more improved functionality. So the ring topology, in a ring topology setup, you have your computers connected to one another in a form a kind of a ring. So each computer in this topology are connected to exactly two computers. Yes, that is one of the major attributes of the ring topology. Each computers are connected to exactly two computers. So once they connect and they form a close connection, it's just like a ring. Failure in one node may lead to a failure in the entire network. It may, because in some cases it might not, and this makes this type of network more robust. Not really robust, but in terms of failure, if one device is failed, of course, if you remove the computer at the top there, computer the other computer can still talk, the three remaining computer can still talk to one another. Then we have the mesh topology. This is when host is connected to one multiple host. When a host is point to point to few, it is called a partial. And when a mesh, the host is point to all. So in a mesh topology, we have two different types of mesh topology. We can say we have two types of mesh topology. We have the full mesh topology and the partial mesh topology. Partial mesh topology is when each node is connected. It has a point-to-point connection to some of the computers within a network environment. But when each computer is connected to all other computers, it's referred to as a full mesh topology. This network, in terms of availability, is most reliable. It is more reliable because failure in either communication medium or one of the devices will not stop the network from functioning effectively. However, this type of network tend to be more expensive. So many lines of communication that will increase the cost. Then we have the tree topology. The tree topology is a combination of star and bus topology. You can have as many servers as you desire. It is divided into co-layer, distributed layer, and the access layer. So if you look at it, it's a kind of a tree like structure with in the access layer. That is where you have your typical computing devices connected to probably your switches. You could, this is just for picture view. You can have many switches and many network layer, more than two network layer connected to the switches, and the switches are connected to a bigger switch or router, and have formed the distribution layers. And of course, the distribution layer is connected to the core layers.